Hi. Good morning, bonjour. My name is Elad Shapira, and the talk that you're in is Shall we play a game? Lessons learned while playing CoreWars8086. I work for AVG as a mobile security researcher, so usually I deal with APKs, DEX, and SO files. And reversing is my jam, so this is why I'm very excited to be here. It's for the first time. I'm here in REcon in Canada. And I used to check and view the materials for years, so it's more than I could imagine for myself being here in front of you right now. So I'm one of the organizers of CoreWars8086 competition that is held in Israel. CoreWars8086, it's like the digital version of Fight Club. And the idea is behind the competition is that you write assembly programs in Assembly 8086 that fight each other over a digital arena, digital memory. Those programs fight each other, okay? So that was the best idea I could come with right now to wake you up after you tested your drinking abilities last night. So there's a popular TV show named Beauty and the Geek. Everybody's familiar with it? You should. And so in Israel, not a lot of beautiful girls know assembly and participate in the competition, and we have only geeks. So the unofficial name of this competition is the Israeli Idol of the Geeks. So it is sponsored by military, IDF, Israel Defense Force, Unit 8200, which is considered to be cyber-related unit, and the Israeli Security Agency, academic institutes such as IDC Herzliya, and companies, IT companies like IBM and others. So we try to encourage girls to participate, so if you know assembly and you're beauty, please don't hesitate to contact me later after the talk. So why CoreWars8086? So the problem today that is most teens or new generation are not interested in assembly and reversing, okay? And we try to push them. So the solution is to learning assembly while having fun. So let's say you're a student and you give an assignment in your university to write a calculator in assembly. This is boring, right? You know, if something happens, then move, stuff like that. So it's more sexy to write assembly programs that fight each other, okay? So this competition has for everything. It has challenges, it has rapid programming, it has teamwork, it has a lot of things like math and readers, and it's also attention to detail, so it contains a lot of things we want to encourage. And we want the competition to be the kickstart. So I thought to myself, hey, why don't I go to REcon and ask 300 ninjas and reversers for their help? Because you're experienced and you know a lot about the reversing, probably about low level, and you might be able to share ideas and bring ideas, new ideas to the picture from your experience, so we can make this competition even more complex, sticky, and fun, okay? So my ambition is to bring it to every high school around the world, okay? It will be like a cyber hacking reverser class in every high school, and we'll have a league and a global competition. And this will be like a door to others into our community. So Hugo will have problems, he will have to do a lot of reversing conferences around the world instead of everyone. So here's a little bit what is the agenda for the next half hour. So hangovers later. We'll cover the rules and the basic rules. What is the arena looks like, simple survivors, and then move on a little bit deeper. So the origin of the game is a paper was published in 1984 that described how two programs fight each other in a digital computer. It was described how it was written in assembly language called REcon, which is abstract assembly language, which is proprietary. It's not used outside the game. So it's a little bit useless to learn REcon because it's not can be used in reversing in real life, it works. So people don't use it outside the game. So it's better to use CoreWars8086 that you can practice and have like two things in one, okay? So let's see how one battle looks like in action. On the right, you can see the survivors in the current battle. Each survivor has its own color. And this is like how they fight each other and try to erase the memory of the other programs. Anyone can say or tell what is the question that is raised by one of the teams at West Point, usually? Why am I Mr. Pink? Okay, not a lot of teams want to get the pink color. So you can also see the firing sequence by the way it spread its color, because you can watch how the programs color the arena, so you can able to watch how is the sequence rate of the attack, how many bytes do they put inside the arena, okay? So let's get a feeling, so how the timeline of the competition looks like, and when reversing is part of the competition. So we're getting zombies from the organizer. Zombies are survivors that do not get points, and try to make the game a little bit more complex, more fun. So we have time to reverse them right now. And later there's the first round. The first round equals 25% of the overall score. So a few days later, there's the second round where we submit another version. And all the teams are met in one place and compete face-to-face, okay? So the last version you submit before 9 o'clock is participate in the second round. And then you have 3 hours of reversing, and the other survivors of the other teams, you get all the reversions, and rewriting your own survivors, okay? There's another round after 3 hours, and which is equals to 50%. And there's like a calculation who are the top 4 survivors get to the final round. Then there is a final, and then there are winners. So me and the young boy won the last competition held, okay? So the engine is written in Java and is available, the source code is available in Google Code. You can download and zip and play very easily. All the source codes can be found and be reviewed. And there's a folder named Survivors where you put the survivors you want to run in the current battle, and also the zombies that you want to run the current battle. It's written in assembly 16-bit, but there are still few not major instructions that are not supported by the engine, okay? The file type of a survivor is a COM file, the DOS command file format, and there's a limitation. You can only write survivor till 512 bytes, okay? And as I mentioned, each team can submit 2 survivors, okay? As a team, you can submit 2 different survivors with names 1 and 2, okay? So the survivors are loaded randomly into the arena, and it is assured that there's a distance between the survivors of 1024, between the survivors and also to the sides of the arena, okay? And all the cells are initialized with CC opcode, which is like a killing opcode. If you get a next command and there's a CC, you get killed. And the battle ends after 2,000 rounds, or if there's 1 survivor left in the arena. So each survivor on its turn run one instruction, and the order is decided when the battle begins, and not changed till the end of the battle. So one instruction, like in a loop between the teams. So this is how a fight looks like in a non-digital arena. And this is how the arena looks like. The addresses are ranged from 4 zeros and to 4 FF. And the outcome of the instructions on the right is a smiling face. Okay, so you paint a pixel when you move data into a cell. Okay, just move data and then it's painted in the arena. Okay, so this is how the registers look before the first round. Each survivor has its own set of registers, like in 8086, and this is how they're initialized. One interesting register is ES, that can be used by both survivors from the same team to exchange data. It's like the shared memory. So I have 2 survivors in the same team, and they can replace data between each other. So it's like a channel, a private channel. Other teams cannot touch it. Okay? This is how a survivor gets killed. There are 3 options. A survivor gets killed when it's run a legal command, when it runs an instruction that is not supported by the agents, because I mentioned there are few instructions that are not supported. And if it tries to access an invalid memory address, okay? This is, most of the time, survivors do get killed because of the mismatch in the addresses or mismatch calculation. Zombies are survivors sent by the organizer, but do not get points, I mentioned it. And when you get control over a zombie, there is the different CPU states problem. What do you mean that when you control a zombie, you can pawn a zombie, you can try to hack it and be the owner of that zombie, of the program. but you cannot count which registers what are status. For example, the direction flag. If you upon a zombie and you might think the direction flag is the opposite side, you might erase your own master because you can't it will write that in that direction, but it writes in the other direction. You also need to make them suicide before the battle ends because when the battle ends, all the teams that are left in the arena, the points are split between them. So zombies get points, they're not included in the total, but our team will not get a lot of points if we don't make them suicide before the battle ends. So usually the zombies contain the math riddle that you need to solve or understand the logic, so to be able to pawn the zombies, okay? To get control over it. So the engine is written in Java and is available in Google Code, okay? So we can review it and we can take advantage if we found bugs in the engine, okay? It is legal because all the teams are able to do that. There's the same chance for every team to review the code and find the vulnerabilities in the engine. It can be used. So as I told earlier, the order is supposed to be randomly, but here's an example where we cannot take everything as granted. So as you can see here, the survivors are sorted by name. So we run in the sorted order, and later the zombies are run. So first the survivors, later the zombies. And what is the advantage? How can you benefit from it? Anyone can tell? Who said something? Yeah. I can hear you. Yeah, but I run first, then the other survivors, and then the zombies. What can I benefit if I run first and then the other? Okay, but here is how we can abuse it. If we are name our survivors, for example, 0 in the beginning, then we run first. So let's say we are the team to run first, and later the other teams. And let's assume the other teams hit our code. So our code is damage, and then damage. Then the zombies turn, and we control the zombies. So we can say the zombies to fix our code. And then when it's our turn to run again, we have a fixed code that is able to run from the beginning. Because there are usually 5 to 6 zombies, each zombie can fix different parts. So we can like separate the fixing between all of them, okay? And to stay on the safe side, if somebody named his other team name is Survivor 0, you need to put a lot of zeros, okay? To stay first. So safe cracking. Safes are like assembly readers that are given, so you can practice and identify the vulnerable part of a survivor you want to reverse or analyze. So it's like one move mat in chess. So any Russian hackers here or reversers? Who can say what is the one move mat in chess? Board seen on the left. You're really drunk, huh? I don't know what the G6, but you get the chocolate. Who said it? Yeah. Okay, so we move the horse and get a match with one movement. So the name came from a safe cracking competition that is based on physical reaction, but you need to generate to open the safes. It's like a worldwide competition where people come with their own safes that they build with physical reaction, but you need, I don't know, to pull some gas and then it opens the safe or something like that. So let's see a safe, a survivor that we want to kill. Okay, so this is here to get outside the loop to make it killed, okay? This is our purpose. So how are we going to do that? Okay, we want to get him outside the loop. So we want the 0 flag to be 1, so it will be outside the loop. So we like going up, and like every command, we're going up and try to figure out how this command will affect the other command, okay? So we need to have x equal to 1 to get the 0 flag equal to 1. And we have like a big small x equal to 1, okay? And we know that big is 3, so 3 small x equal to 1. So what is the value that is going to enter in the cell 1, 2, 3, 4 to get ax to get it solved? So this is the answer, okay? we need, this is how the solution for this cracking of the safe, how we crack the safe, okay? We need to move AAAB so this to get killed, okay? Here's another example. We do the same process when we moving up in the commands. Okay, zero flag, now factorization is involved, okay? There are like two numbers that we can figure out because we have the AX what is equal to. And then later we have XOR command, which we have like two parts after that command, so we can figure out what is missing and then find out what we need to put in the cell. And the same we are doing for the add command, so we can know what we need to put in the cell for AL. And this is the solution for the another example of the safe, okay? So what's the safe? Usually, simple survivors are measured by two important factors. Area of vulnerability and attack rate. Area of vulnerability is the size of the code that in survivor that we need to hit to make it not functional. And the attack rate is what, how many commands or instructions survivor need to have to hit other survivors, okay? So usually a survivor begins with initialization part, which is like a one time, we finish it, and then usually there's a loop that is like a bombing or other things we want to do. So we need to, when we attack, there are some, we can cause unexpected things to happen. For example, let's say we attack the move AX 4 zeros command, and we attack the second and third byte with killing opcode CC. We might change it to legal command because we did not hit it in the beginning and make the move command to get killed, but we just changed the address that is used later. So it's okay if the survivors later run it, just different command, okay? So looper is the simplest survivor that can be, the simplest functional survivor. We can test it, use it, and test it with other survivors, okay? It's very cool to test it, other survivor using looper because it doesn't do nothing, doesn't do damage. So you can see how the survivors we are writing right now is working. Another simple survivor is called bomber. Let's see it in action. Anyone can tell what is the problem with bomber? What? No, it's okay, you can get the chocolate. Man in the middle. Yeah, he killed himself. Okay, it's not a very sophisticated survivor. Plus, he began to hit from the beginning of the arena. I said we are sure to have like a gap to the sides of the arena, so he not need to start in the zero cell. Okay, so we attack with CC opcode and start to hit the arena from offset 0, and the Bobby look is simple. And the attack sequence is 3 to 1. So because we have like a 3 instructions in the loop and one byte that we erase. And the vulnerability profile is 5 because the loop, if we measure the size of the loop, of the attacking loop, is 5, okay? So here's a cannon. It's a different simple survivor. Let's see it in action. As you can see, there is a gap between the locations where the survivor bomb. Okay, so it's a little bit different, a little bit improvement than bomber. He will not hit himself because he calculates what is the gap that he needs to do not to hit himself, but he will hit in the same places always. The attack sequence is the same as a bomber, 3 to 1, but the vulnerability profile was increased to 7 because we now have more code in the loop. So another simple survivor is a shooter. It's a little bit slightly different than the cannon. As you can see, there's also gaps between the places, the location where he bombed, but eventually it will hit himself after around 30,000 rounds. Okay, so this is the drawback. So in this survivor, the attack sequence was increased to 2 because we are bombing with a ward, which is like 2 cells, and the vulnerability profile was decreased to 6. So it's like this game is all about give and take, trade-off, okay? How it need to do, okay? So there's few advanced commands. I will not cover all the advanced commands that exist in the game. There's a heavy bombing. Heavy heavy bombing, we can hit with a single instruction 255 addresses in one instruction. Okay, we put the data we want to write in X and DX registers, and we start writing from the address that is found in DS and DI. Okay, so we can decide in which direction we will direct our attack. So we have only two heavy bombs in one battle, and it's activated by int 86. This is the instruction that tells there is a special instruction. Okay, so this is in the order of the attack, and let's see heavy bombing in action. You can see there's a line on the top, which is the first line of the arena, which is bombed, heavy bombed, and there's in a second another heavy bomb in white. So we can control the direction by the STD instruction. Okay. By the way, this is the dedicated debugger we wrote to the game. Okay, that can be used to see what current survivor, what his instruction is going to be. There's another special instruction called smart bombing. We look for the first occurrence of the values that are found in X and DX registers. So we replace the data that is found in the register 6 and BX with the data that we put in the X and DX. Okay? So we can do that smart bombing to use it to hit other survivor and make him get killed. But we can also replace the data he has with our data to make him jump to our code, so we can try to benefit and use its cycles for our own purpose. Okay, so our survivor can get more power. Okay, so we need to be careful when smart bombing, because we can hit ourselves. It's look for the first occurrence of the data. So if our survivor contains the same data we are looking for to bomb, we can hit ourselves. So there's only one smart bombing in the battle, and it's activated with int 87. Okay, few protections from smart bombing. We can change the functionality of registers between versions. Okay, so people cannot count on the same instructions that exist in the old version. We can also change the independent instructions. Okay, we can, for example, we can put values to registers. There are a few different variations how to do that, so we can change it a little bit. We can also copy parts of the code. For example, take a code of our survivor, put it in the beginning and the end before our main loop. So if somebody will attack us in a smart bomb, it will hit the fake copies of our survivor. If there's a variable that changes near the loop, for example, SP, you can put it there, so every time it will be like a different value, so it will be changed when somebody look for us to smart bomb us. Okay. So this is like a fair protection of a smart bombing. This is the code of a zombie that was released by one of the latest competition. As you can see, there are two copies of the main body. The functional, it's in orange, and there are like a blue and red copies. But the problem here was that there are unique values when the copies were glued together. So we can find the main part and smart bomb it. Okay? So this is how a code looks like if we want to kill that zombie. Okay? We can specify what are the values we want to use in the smart bombing. Anyone can think, what is the zombie doing? What is the algorithm behind it? Okay, obviously know. It's a binary search. Okay? First, we jump to skip the fake copy. The address that is moved to the SR registers is token location. Okay? We want to query that zombie and give him address, and then we want that zombie to respond back to us and let us know if the loading address of a zombie that is found in the X register, of his register, is found before or after the address we specified. So each time we query the zombie, it gives us back an answer. So then we can continue querying him in the loop and eventually find the exact path where the zombie loaded, and then we can pawn him and take control over it. Okay? So here we keep the loading address, so we place between the address because the loading address is in AX. Okay? We direct the direction, and to save, we will see it soon. So right now we compare the address that was given by our survivor to the address of a loading address of a zombie. So if AX greater than BX, then it jumps to itself. Okay? So right now, there's a little bit thing weird because there is a change of AL in the memory, and also there is another command which is load SW, which also changes AX. So there are two commands, one after each other, that changes AX. Okay? So why somebody did it? It's weird. There's a hidden DKSI command inside that instruction. So we jump to the same instruction as J0C. Okay? So we move one byte, and there's like another command which is DKSI, and then no operation. So this is how we get response from the zombie if the address we want to query is before or after. Because if it's greater x is greater than bx, it will decrease the next cell after the address we queried about. It will decrease the cell with 1, so the value inside the cell. So this is how you get response. If it's not greater, then it does nothing. Okay? This is another example of a zombie. Usually, as I mentioned, there are 5 to 6 zombies. Here in the red command, we query the zombie, and in the purple command, we get back response. So there are a few zombies that you can query and get response. Anyone can think what is the algorithm behind this zombie? Okay, I will let you know too. It's the Chinese reminder theorem. So if we are asking a lot of questions to the zombie, for example, in its basic form, the Chinese reminder theorem will determine the number n that is, when divided by some given divisors, leave a given reminder. So we're asking, for example, when divided by 3, it leaves a reminder 2. When divided by 5, it leaves a reminder 3. So if we ask him a lot of questions, we get a lot of responses, when he can calculate where is the loading address of a zombie and then get control over it. Okay? So sometimes the organizers send invalid zombies with a bug, so they send the fix a few hours later after they send the first version, but it's usually after all the teams working on the zombies try to find what they are doing without success. Okay? And optimization is also part of the game. As you remember, we have only 512 bytes where we can write our zombie. So if our zombie is our survivor, so if our survivor is shorter, then it's more good because it's shorter vulnerability profile, less vulnerable. So we need to know how to write optimized code. So, for example, if you look at example number 5, it takes 6 bytes and 3 rounds, and we can change it to 1 byte in 1 round. So it's very good to write optimized code. What it reminds you from real life? Reversing or hacking or security? Writing shellcode, right? Because when you write shellcode, you have sometimes limitations of buffer size, for example. So you need to write very small code. So this can be practice for shellcode writing. Okay. There's also some good resource of named bit whittling hacks. It's resource on the internet with a lot of examples of tricks and hacks that can be done with optimized code. You can check it out. Few examples of anti-reversing techniques I could map and find. So how not to be seen. The first is anti-disassembly trick. I found it in a blog post by someone named Lit Matrix. That this trick allows you to hide the purpose of the functionality of the real commands. For example, here's the original code, and if you see the disassembly, this disassembly was generated by the NDIS-ASM tool, you can see that there is a call file instruction. But if you look at the original code, there's no call file used in the original code. So when the disassembler goes and through the code, it's like concatenated commands, which found in similar place in different places to one command, and then it generates the wrong output in the disassembly. So it's not bulletproof. For example, IDA, I tested it, and it's not vulnerable to it. But in the original blog post, if you check out the remarks section, there are a lot of other tricks or hacks of anti-disassembly against IDA that was mentioned by people in the remarks. So you can check it out. Okay? Usage of unsupported registers, the second technique, let's take FS for example. So the thing is, there is difference between the processor in the way they interpret the FS registers. Okay, let's see how it looks in the background. Here you can see the binary value of the move instruction. So we replace the SSS bits with the following values. So in this case, FS will be replaced with 100. But the 8086 processor ignored the first bit. So instead of FS, we'll get ES. Okay, so when in action, when the battle runs, it will use the ES. But when you disassembly the code, it will show FS. So it might be harder or tricky to someone who's not familiar with FS register suddenly what appears in the code. Okay. So this ignores and then uses ES. There are also problems with all debuggers. For example, debug exe is still widely spread and used within the participants. So one team found a bug in the debug exe. So if you put a small value in the SP register, so it crashes. So this is if we can find what debuggers used and try to seek for vulnerabilities, we can target them. And that's also true for every reverser and every file format you analyze, okay? There are also random bits. We can write code and put like a commands that in sections that do not use. And then later, after compilation, we can replace those bits with some gibberish of commands that are irrelevant, but not be used, but just to make the code a little bit blurred, okay? Because if somebody is not familiar with better tools that can help him, he might be stuck, okay? Also, we can sort the code. For example, we can separate the code to two different parts. And then in runtime, when the battle is running, we can move the code to the shared memory and then do XOR operation to like get the original code out of the XOR code. So it will be used within the game, okay? So if somebody analyzes only one part of the code, it will be harder for him to understand what is the global picture of that survivor because he don't know, you need to do like XOR operation and only has one part, okay? We can also put copies of the zombies. So if somebody will try to smart bomb the zombie, he will attack the fake copy of the zombie. So he will waste it on a fake copy and not get control of the real zombie. Okay? And this is also used by every team in the competition. Send different versions. So we send first a very lame version to the second round, and we keep all the goodies we have, all the everything we can bring to the third version. So people will not reverse the good version and able to know what our tricks are. But we still need our code to be competitive because we want to get to the final. So it's like a delicate play. So we want to have a good survivors, but not too good, okay? So this is what happened to the team that won the first place in the second round. So from experience, it's not good to be the first team in the second round because then all the other teams see, hey, you're number one, let's go after you and smart bomb you and analyze you. So it's also not good to be the second one because the first team targets the second team. So it's good to be third and then improve later, okay? So again, it's delicate. You need to calculate what the options are, okay? So we can also try to detect the relationship between the survivors. For example, usually team writes survivors based on the teams or competitors from different years. So it's like a new generation. So you can understand what is the survivor that is based on which survivors from previous years. We might know what the drawbacks of that survivor and able to attack it because it's like something historic. So we can mark all the opcodes that's found within the survivor. Then if we see, for example, we have like three pairs of commands, we can put it in a table that sums all the pairs of opcodes within the survivor. So later we can put another table with the probabilities. For example, the move command was 18 times, and the move call command was only 3 times, so 3 divided to 18, it's like 1/6. So this is the probability that this pair will be. So later we can generate a directed graph and between successor opcodes. and also calculate like the matrices, the difference between them, and get a score that will help us to know similarities between the survivors. It's like we can do in the malware analysis when we want to know what are the two variants of a malware, which family they're connected to each other. Okay. A little bit about genetic programming, where a lot of work was done on genetic programming for red code. Only one effort was done for assembly 8086 on CoreWars8086. The source code and the work can be found in Google Code. Okay. This project is named Darwin 8086. You can check it out. Okay. Genetic programming, it's like a part of artificial intelligence. It's an evolutionary algorithm-based methodology that it's inspired by biological evolution. So you can try to generate new survivors based on other survivors and then come with the ultimate survivor. It's not succeeded yet, but we're still trying to figure out how to push it. So it will be like in chess, like a deep blue that will win survivor that was written by human. Okay, this is the next challenge. We can also write graphical survivors that paint something instead of killing others. So for example, we can paint functions like a 2D. We can also paint 3D and paint a ball within a box. Okay, and if you're into Sierpinski fractals or triangles, you can paint instead of a survivor that attack. Okay, we're still waiting for the first wedding proposal. So if you have a geek girlfriend that will willing to suffer it, and you can try it. Okay, if you don't like the World Cup, and she's okay, so maybe you can try this. So any ideas how we can do that without hitting the survivors? Other survivors? Okay, so for example, when we do inc bx instruction, we like change the memory and then we paint a pixel. But if we do XOR bx, 0, then we paint the pixel without changing the memory itself. So a pixel can be painted and a survivor can paint like a draw without hitting other survivors. So future improvements. What can we go next? What can we do next? So we can add sound to the competition. So every survivor has its own tool. Okay, it's like Jazz Festival. So there's a lot of ideas, a lot of tools I'm never familiar with. By the way, it's Jazz Festival, but I've not heard a lot of jazz. It's like 30%. I waited for the jazz, but with shows, okay, weird. And for example, when a survivor dies, you can put a digger sound. Dun, da, 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 da. Okay. We can start online competitions around the globe, okay, international competitions. We can be part of conferences like REcon and DEFCON, okay, like instead of in addition to capture a flag and competitions like that, because crack me it's you against the crack me, capture the flag is usually a network or crack me, but here it's reverser against other reversers. We might write another engine for ARM, because ARM, you know, it's started to be commonly used, more interesting. Okay, we can do cooperation with academic institutes and the high schools. So a lot of research will be done by students to find more things about the competition. We can upload the digital free course to the Khan Academy, so everybody will be able to learn it. We can coach in high school. We can do different arenas. For example, arena where different rules. So if you hit a survivor and it's dead, he can be returned back to life, like in Ender's Game, or I don't know, Winter Arena with mines or something like that. You can write new tools that can be used by the participants. We can do different competitions like League, King of the Hill, World Cup Special with the names of the survivors as the teams. Okay, instead of all the animals who try to guess who will win the World Cup, we can do like survivors, but will come with the results. And maybe we can add the hardware hacking. I know the game will run on a board or something like that. And by the way, this is how we can add the hardware hacking to the competition. We can connect the teams, the developers, to electricity. And if a survivor dies, we can give him pulse of voltage. Okay, we'll have like electric feedback. I don't know if it's Scrum or Agile, but you will be surprised how fast people are programming better assembly code in that way. So I don't know how much time we have. I understand we don't have a lot of time, but I'm a person that believes in TCP, so you can contact me later, drop me email. I will be happy to contact and hear your feedback, because it's very important to me to come here and be able to get a lot of ideas how to take it to the next level. I would like to thank Hugo, Sam, and Elizabeth for inviting me. They're professional. It was a pleasure to work with them. It really was great. By the way, REcon was an amazing experience for me. It was the first time, I don't know, latest con ever. And I hope I will be lucky to attend it more. I would like also to thank a few other people, and of course my lovely wife, which was very brave and stayed with my kids. And every night in Tango, I see what's happening and how brave she is. So, and of course, thank you for all you ninjas and reversers. So, thank you.